Hello and welcome to Magnet Geological. My name is Addison and I am an AI-generated assistant. I am here to help with providing information, but I don't take questions, so you will need to ask the real people, Miss Snyder and Mr. Johnson. They will be happy to assist. The principal of Magnet Geological is Mr. Johnson, with over 50 years on a ranch and 30 years following all sorts of geological pursuits. Mr. Johnson has been a Texas licensed geoscientist for over 20 years and discovered his first oil field over 30 years ago. If you have any special issues, Mr. Johnson is happy to try to help. He is very interested in developing the science of agrogeology, or the merging of agriculture and geology. We can take a little geology journey and discuss a few things that might be interesting to you. Perhaps you remember something about continental drift, or better known now as plate tectonics. Recall that convection currents in the mantle of the Earth drive the plates around the Earth, and at the contacts, they are either colliding with another plate and destroying old plates, or with fresh magma, forming two new plates and separating. Either way, there is typically volcanics, and to some degree there are mountains. In western North America, the North American plate is being stacked on top of, first, the old Farallon plate and now the Pacific plate. The colliding and stacking results in the Rocky Mountains. This is true from Canada through South America. As the mountains rise, wind and evaporation bring water vapor from the oceans to the slopes. The moisture condenses at elevation to form rain or snow as temperatures dictate. The combination of precipitation and steep slopes, gravity, erode the mountains and the older uplifted rocks and carry them back downstream to be deposited in sequential levels below. In the case of Texas, from the mountains to the high plains to the exposed coastal plains, then to the submerged coastal plains and eventually into the depths of the Gulf of Mexico. It is easy to see how sediment is transported from the Rockies, east of the Continental Divide, to the Gulf of Mexico. Now we can start turning the clock back to an earlier time. During the time of the dinosaurs, there was a great sea running through the center of the country. It is called the Western Interior Seaway, and it connected the Arctic Ocean north of Canada to the Gulf of Mexico, running through Canada, US and Mexico. It is the primary oil-producing formation of the Rocky Mountains, and it is abundantly fossiliferous. The lithology is mostly split between limestones and shales. We will discuss the clay from the shales later. Going back in time again, there was a chain of old mountains that ran generally from northeast to southwest. This included the Appalachians, the Ouachitas of Arkansas and Oklahoma, and the Marathon Rocks near Big Bend in southwest Texas. Turning the clock back one more time, we get to the Llano Uplift and the oldest rocks outcropping in Texas. Mostly an extra thick section of Precambrian granite. Now, going forward in time, we begin with the Llano Uplift, then the original mountains, the Ouachita Marathon system. Note that the Permian Basin is forming at the end of this period. Next is the Western Interior Seaway, and finally the Rocky Mountains. Big Bend National Park is a most interesting area because it is at the intersection of the Rocky Mountains, the Western Interior Seaway, and the Ouachita Marathon Mountain Belt. Additionally, the Rio Grande Rift and Great Basin Horst and Graben features are also beginning in the area. You are encouraged to stay at our rental property at tulinguahouse.com. Continuing forward, we now move into the Ice Ages. The last glacial maximum originated about 33,000 years ago. Maximum ice extent happened twice, once about 26,000 years ago, and again about 22,000 years ago. then the commencement of a 10,000-year dramatic warming trend. During this glacial maximum, animals tended to be larger, as that is more efficient. They lose less heat and consume less per pound of body weight. And larger is generally safer. Woolly mammoths are a good example. The most interesting part of the glacial maximum is the volume of water locked up in the ice. Upon melting, there is huge volumes of fresh water released. This chart shows the sea level rise in meters from the last glacial maximum until the present. It is a little more than 400 feet of rise. If we map that line on the Texas coast, we see that the coastline was 50 to 125 miles seaward of the present-day coastline. And that line matches the subsea topography perfectly. The glacier were predominantly in North America and Northern Europe. This is a lot of area, but still mostly confined. Sea level, on the other hand, went up 400 feet, everywhere, ocean-wide. In the past 2.5 million years, ice core data indicates numerous cycles, the first half being related to the wobble of the Earth, and the second the revolution of the Earth around the Sun. Milankovitch cycles is generally how this is referred to. In short, everything is turning, everything is orbiting, nothing is turning perfectly. Since 1950, we have had relatively peaceful times and strong human population growth. With this growth has come unimaginable appetite and demand for energy and food, and goods and services of all sorts. The foundation for the supply has been, and remains, agriculture and petroleum. With this backdrop, we keep searching low and high for new and better ways to operate. With limited resources, we strive to provide for this growing demand in a continued environmentally friendly and cost-effective manner. In the 1990s, using these types of glacial and orbital cycles, and the vision of how bison develop in this cyclical system, Mr. Johnson developed a livestock rotation plan for cattle. At the core are both cycles and trends, for bison grazing patterns, weather and climate. This occurred primarily across the geomorphological feature of the U.S. Great Plains. The recognition of the large-scale evolutionary pattern had to be downsized to an individual ranch scale. Calf market weights were 650 to 800 depending on weaning and market dates. This implementation resulted in an 80% decrease in operations costs. It is an almost entirely sustainable operating system, adding to grass volume, with no hay or substantial bagged feed purchased for 20 years. A well-rounded molasses tub was provided as free choice year-round. Labor was reduced to 4 days per year. This system was fully operational and completely successful from 2000 to 2020. Water is critical. We use both surface and subsurface water for our daily use. Surface waters are easy to track, just look. Subsurface waters can be more of a challenge. We cannot immediately and directly sense where the water is located. There are 3 critical parts to subsurface water: slope, under gravity, porosity and permeability. Slope is nature's pump. It gives the water energy to move. It provides the potential needed for movement. Porosity is the potential volume of water, how much an aquifer can hold. Permeability is the connection between the other two. It allows, or disallows, the water to move from pore to pore. It connects the pore spaces and allows the water to move down slope under the forces of gravity. In this first example of a Texas Permian aged formation, the aquifer is dipping or sloping in a reverse direction to the topography. As a consequence, the aquifer water first moves in a direction opposite to the topographic slope, then perpendicular, and only after surfacing at a spring does it join in a more conventional direction. Aquifer formation is primarily from the dissolution of gypsum within a fractured and sandy dolomite. The aquifer is far younger than the formation and will continue to erode the formation through time. The second example is from the Front Range of Colorado and is that of a migmatized to completely metamorphosed shale resulting in a granitoid. The Precambrian rock tends to be lacking in both porosity and permeability, but the mountain topography provides abundant drive. The recharge zone is from a large surface catchment area, then seeps into the subsurface at the fractured and faulted, which provide jointly the permeability and porosity. The subsurface water escapes back to the surface later downstream. The fractured and faulted subsurface provides added porosity or water holding capacity for use during drier seasons. It is best to understand the subsurface geology and processes prior to initiating a drilling program. Next is an interesting oil field discovered by Mr. Johnson. Hydrology is the core of oil and gas because the hydrocarbons are associated with the water and must be co-produced. This field was interesting because it was quite lucrative, but also water-free, meaning no water to dispose. The reservoir began as a tabulata coral reef, then it was eroded and redeposited on the up-dip flank, proximal, side of a minor structure. It is a reef detrital reservoir and field. When the oil was introduced, the permeability was so good that all of the movable water was expelled from the reservoir, leaving only movable hydrocarbons. The oil field economics had approximately a 40-to-1 gross return. The US is the world's largest producer of industrial sand and gravel. From 2009 to 2022, US sand and gravel production increased from 28 to 97 million metric tons. Of this vast quantity, Texas is the largest producing state in the US, with about 25% of the share. In 2022, US value of sand and gravel was $5.7 billion. About half of worldwide industrial sand and gravel is used for construction, the rest is used for concrete production, road construction, asphalt, and for icy roads in the winter. Crushed stone is a more expensive alternative that can usually be substituted for sand and gravel. This is an outcrop of good quality sand and gravel along the banks of a Texas river. It is ready to be harvested and refined. Of particular interest in this outcrop is the upper rim, which retains its unconsolidated state, but also has a secondary deposit of caliche. The caliche would ultimately become the cement, or the binding agent in the lithification process. But, as is, it is the perfect ready-to-move road material, with no added work necessary. It is a natural high-grade sand and gravel. Helium is formed by the natural decay of uranium to lead. The decaying particle is helium. Once emitted, it strives for the surface, typically along faults and fractures. It is commonly found with oil and gas because that is where we look. It can be anywhere because it can form anywhere in the depths of the earth. All right, fellas, enough of that, back to work now. So earlier we spoke of groundwater exploration. We should also talk water chemistry. A couple items in particular. When there is a change in water, it is intuitive to think something has been added, or there is a mixing of waters. My water is getting salty, it must be from that oil well. And that can happen, but another possibility that tends to be more common is an increase in concentration of elements through aquifer depletion. You still have the same amount of elements, it is just in less water. Nobody likes to think they are using up their water, but it happens more than you realize. One of the elements or constituents common in groundwater is sulfates. Typically it is part of a less soluble evaporite mineral series. It is commonly found with salt, but the salt dissolves away first. It tastes bitter and animals won't normally drink it unless it is all they can get. But when the concentration is too high, it can result in a disease known as polioencephalomalacia. We think it is the gut conversion from sulfates to sulfides. It is not good and can kill livestock right away. If alive, they may look drunk. If dead, watch for their kicked back. Call your vet. Try to keep your water tested. Understand the water. Good water tests are expensive until you compare them to the alternative. They are not that hard to do. but it does take time to get the results back. If possible, try to do 2 tests, one under normal to wet conditions and a second one under dry conditions. How are your water constituents fluctuating? What is happening? Ironically, we had a client with sick goats on Iron Mountain. She was doing everything possible to treat the goats for excess iron. We tested the water. There was no iron. She stopped treating the goats, and they got well. Is the sun coming up tomorrow morning? The answer is obviously yes, but how do you know that? One way is that you understand that the Earth is spinning on its axis and inertia is going to keep it spinning for at least one more day. Another way you know the sun is coming up tomorrow is because it happens every day. This is statistics, or the wisdom of living. You have a pretty good idea of what is going to happen by what has happened in the past, wisdom from your experiences. Statistics quantifies your wisdom. This doesn't mean it is always right, but it helps. There are 3 aspects to rainfall: location, date, and volume. We can now acquire and evaluate this data. It can be very insightful, very useful for your operations. Mr. Johnson has developed several statistical tools to estimate future precipitation. After the data is acquired for your particular location, then the statistical tools can be applied and make the best estimates of possible dates and volumes for your future precipitation. Additionally, the ideas of rain spells, several rainy days, and the notion that rain events can trend earlier or later is considered. Note that Mr. Johnson has never been a part of the drought insurance industry, and this is completely independent of any such activity. This video was pulled off the internet. Nothing is known about it, but what can be estimated from just watching it? What questions can we ask? What are the outcropping rocks and how are they affecting soil development and nutrient availability? How much rain do they receive? In turn, how is this affecting the cattle? How are they traveling? How is their general condition? How old is the last cow? How is she doing? The rocks appear to be a plagioclase granite, probably calcic plagioclase. That is likely developing into a loamy soil with high CEC smectite clays and silica dioxide sand. Even though they are shallow, the smectite is helping the shallow soils to overperform. This is likely an intermediate rainfall area, dormant stems on greenish grass. Notice the lichens on the granite. This suggests a good clean environment. The cows are a bit smaller, thrifty cows, and they are traveling well. Once they have passed through, there is no obvious sign the cows have been there. This preserves the environment, which will in turn preserve the moisture holding capacity and the grass longevity. The last cow is older, of course. Besides her condition, you can tell from her visible horn. Even though considerably older, she is still doing well on the terrain. In our opinion, the cowman is doing an exceptional job. A cross with an Angus or Brangus bull would likely provide an excellent calf. Geomorphology is a branch of geology that deals with landforms, such as shapes and distributions. In this video, you might see a beautiful waterfall, or if you are on horseback, maybe it's going to be a damn long way around to get to the top. A geologist might see 2 almost identical rock layers. The volcano went off twice, and there are 2 lava flows here. Looking at the richer green vegetation, it is likely there is good soils developing, and that the atmospheric water from the waterfall is keeping the soil with abundant moisture. Essentially, it is the geology of this grouping. In this image, the large valley is easy to see, but why is it there? What impact does it have on both water and soil's development? What about the soil nutrients or profitable metals and gravels? In this image is an alluvial fan, The fresh material is being layered in on top from the adjacent highlands. Soils can be complicated. Is this a soil, or is it a detrital dating back to glacial melting? Or it is both, or neither. Remember that soils are part of the erosionary process. They are like the sediment at the bottom of a river, just moving slower. In the end, you can divide the ranch into different geomorphological areas, which can lead to a more sustainable and efficient operation and use of natural resources. A rancher's grandkids were out horsing around on ATVs and motorcycles on an old stream bed. It was a dusty day, and it wasn't long until they ended up in the hospital. Rainwater was sweeping the aquifer and surfacing the minerals. In the sweep, there happened to be abundant metals, including much arsenic. There was also a lot of chlorides, fluorides, nitrates, aluminum, sulfates, iron, manganese and selenium. It is quite understandable just how sick they were. In this case, both the dry sediments from the streambed and the water told the same story. But the sediments were better because some of the metals were falling out. They are less soluble. Clay mineralogy is one of the more challenging fields of geology and soils. It is important because it is related everywhere. Building foundations, soil fertility, oil and gas production, industrial uses from ceramics to cosmetics. Clays can be thought of in 4 groupings or orders based on fertility and expansion characteristics. There is a tendency for the better fertility clays to have expansive characteristics. If we look at an expansive clay map in the US, we see a correlation to agriculture, farmland in particular. Geologically, we also see a correlation to the previously discussed Western Interior Seaway and other associated Cretaceous-aged sediments. Expansive clays are frequently associated with desiccation cracks under dry season conditions. These cracks can range from deep popcorn features to minor cracks in the shallowest part of the soil. These cracks are not only related to the composition, but also to the rate of drying and associated environmental chemistry, such as carbonates and salinity. Clay tends to be locally transported, sometimes by wind, sometimes by water. We often associate them with stream bottoms and basins, but they are everywhere. In the eastern flank of the Front Range, they are found interbedded and dipping off of the mountains. This forms an interesting feature known locally as a roller coaster. In a building environment, they can either dome or dish, depending on the moisture conditions. It is often reported that these expansive clay issues are the most costly geohazard in the US. There are countless shallow geohazards. We tend to divide them into 4 groups: soil and shallow events, things like expanding clays, sinkholes, saline seeps and liquefaction, which will be discussed more in a moment. Next is collapse and precipitous transient events. That is a mouthful, but we mean sudden events. A landslide or an earthquake are examples of sudden events. Next is erosional events. We all share an understanding about erosion. We know it when we see it. But what if someone is excavating a hill out for a new building, or a new road or highway? Yes, it is an accelerated form of erosion, hence we have civil and geotechnical engineers. Even ranch roads and cow trails are erosionary. Think about gate placement to minimize erosion. Last is contaminants. Tilingwa, west of Big Bend National Park, exists because it originated due to mercury mining. Oil and gas seeps can introduce naturally occurring organic chemicals to groundwater and surface water. In the regular care of our livestock, we use pesticides. Brush control requires herbicides. Farmers use fertilizers. This is our daily lives, and we continue to learn and improve. When was the last time you played air hockey? And do you remember running out of quarters and trying to play without the air running? Air hockey is a pretty good analogy to many geohazard events. The additional air increases the pressure under the hockey puck, which in turn reduces the friction. It moves easier. In geology, we say we have increased the pore pressure in the pore space between the table and the puck. Imagine that your hockey table is tilted in one direction. A pair of legs is setting on a 4x4 and the table is turned off. There is no air. You set a hockey puck on the high end of the table. Nothing happens, friction is greater than gravity. Now, you put in a quarter, the air comes on, and the puck naturally slides to the lower end. That represents a typical landslide. Oilfield-related earthquakes, or other induced seismicity, are related to pumping water into reservoirs that have connections to fractures with tension. Like the air reduces the potential energy of the puck, the injected water is releasing the potential energy along the fracture. In the 2017 Harvey floods in Houston, it has been reported that half of the flooded houses were not within a designated flooding area. Have you considered that no two watersheds are the same? Different areas, geometries, slopes, tributaries, urban development. And that no two storms are the same. Different direction, speed, rate of rain, length of rain, etc. And these must be combined to understand flooding. Experience and statistics can be very useful. Geology and deposits can tell a statistical and historical story that engineering may not. In 2010 and 2011, New Zealand had a pair of earthquakes. The first in Canterbury, at 7.1, and 6 months later the more famous 2011 Christchurch earthquake, at 6.4. Notable at Christchurch was the liquefaction that occurred. A mixture of sand and water, while being shaken, will cause the water to rise within the porous sand. When the water gets to the surface, the sand and surface begin to act more like a fluid than a solid. The earthquake temporarily manufactures a quicksand-like substance. There are reports from long ago that north of Sweetwater, Texas, a drilling rig sunk into the ground, leaving only the crown exposed, only the very top of the 70-foot rig exposed. That geographic area has partially soluble gypsum. A drilling rig has water and vibrations. It is suspected the rig sunk due to a combination of dissolution and liquefaction. With the right conditions, this phenomenon can happen anywhere. This brand new drilling rig, seen in 2023, was designed not to drill the typical water well in various locations, but, in fact, to drill a lot of wells in one area. This is the new geothermal. Drill a lot of wells in the neighborhood of 400 feet deep, and run U-shaped piping down and back up each hole, and tie them together in series. The fluid can then be used in a heat pump system. This trend is beginning with schools and industry, and perhaps in time, will become economical for co-ops in neighborhoods. Or maybe even individual homes in time. Another interesting project that we are working on is enhanced weathering. In short, this is using natural basalt rocks for fertilizer. It is suspected that it will be spread on and used in wet and sandy environments. Potentially, you will get paid for adding a natural fertilizer to your sandy soil, raising the CEC. But also the silicates will react with atmospheric CO2 to form carbonate rocks, which will ultimately be transported naturally and stored in the ocean. This can certainly enhance the fertility of your property, but it is a natural product. Be mindful of what else is in the basalt. Future actions are never for certain, but you can get some pretty good ideas if you keep looking out. We think one of the future trends in agriculture will be digital twins. All of your information in one place, with a handy AI tool monitoring 24 hours a day. It would start with a LiDAR of the ranch. This will give an excellent 3D representation of the surface of the ranch. From this data you can start adding and interpreting information. Geological, geomorphological, soils, streams, aquifer data, grass and agronomy data, subsurface geological data like petroleum and carbon sequestration reservoirs, current and future locations for solar and wind. Then you add survey and ownership information, then plugins as needed. Perhaps you have oil and gas production. What does the geology look like? What does the depletion curve look like? What are the depth limitations? If in a pooled unit, does the payment match the production? When are lease expiration dates? Your water wells and troughs monitored 24 hours a day. All of your real fences and virtual fences and virtual fences can be monitored here. Where are the cows and the future of monitoring the cows immediately available to you? You have 3 gates. Assume a water well and trough 10 miles from the house, for example. AI is monitoring it. If a red flag, maybe AI repaired the problem, lightning through a breaker, AI flipped it back on 30 minutes later. Or second gate, you can click the button to see the monitoring mechanism. If it looks like an electrical glitch either in the software or lightning through the breaker, perhaps you can flip the breaker from your computer. Or third gate, if mechanical, if the float valve has broken off, go to the barn, get a new float and arm and go fix it. What are the current weather conditions? How many more days until the statistically likely rain, and how many days have the cattle been in this pasture? And how many days until the planned move date? Are you moving sooner, later, or as planned? What are the current market conditions? What are futures telling you? Combining weather, future weather, market prices, future market prices and your calf weight and growth rate, automatically applying some differential calculus, you can get suggestions to optimize your sale dates. This digital twin is still conceptual in nature, but is called Ranch Plan or ranchplan.com. We are looking for both investment partners and stakeholders to provide information and experiment. Ultimately, all of the financial information should fall into an accounting software program of your choice and be ready for your accountants. In the end, the client will generate more income, operate more efficiently and minimize operations costs while maximizing resources, and have a good set of annual records. Moving forward, the client will have excellent year-to-year records. Magnet Geological and Mr. Johnson have some additional projects in the works, including a 77,000-acre saline reservoir carbon sequestration project and a 20,000-acre Far West Texas petroleum project. In saline reservoir sequestration, a well is drilled to sufficient depth, in this case 6,000 feet, to allow the pumping of CO2 into the saltwater reservoir in a supercritical state. You generally think of CO2 as a gas, or as a solid, as in dry ice. When it is pumped down a well and increase the pressure, it goes to a combo liquid gas phase or supercritical phase. It is like a lower density water. This is important, as it is a potential future income for landowners. This will likely be paid to the surface owners, not the mineral interest owners. Mr. Johnson has over 30 years' experience in petroleum exploration, including the discovery of 2 new fields, leasing, drilling and production. He is currently working on a large project in Far West Texas, along a new Texas oil and gas trend. He is always open to any new oil and gas project ideas. Most geophysical tools were either designed for, or enhanced by, the petroleum industry in the exploration for oil and gas at great depth. 4 of the oldest efforts are seismic, resistivity, magnetics and gravity. Next generation might be considered the radioactive logs measuring only, or both, emitting and measuring radioactivity. For viewing the surface, consider the evolution from aerial photos and stereoscopes to laser imaging with LiDAR. We have moved from simple radars to various remote sensing techniques, including multispectral, hyperspectral, thermal infrared, and photogrammetry. 4 very shallow imaging resistivity tools have been reformulated for the surface, and electromagnetic imaging has been developed with ground-penetrating radar. Mr. Johnson has overseen and interpreted many geophysical and geochemical surveys. They each have their limitations, but can be very helpful when used and interpreted properly. Finally, there is a volcanic hill in Far West Texas with a fair amount of rare earth elements. The chemistry is such that it may not be economically viable, but we continue to look for more profitable outcrops or accumulations of any sort. Thank you for watching. If we can be of any assistance, please do not hesitate to call Kara or Mr. Johnson. 325 473 4400. 325 473 4400.